A small block of mass m is kept on a bigger block of mass capital M, which is attached to a vertical spring constant K as shown in the figure. The system oscillates vertically. Find the resultant force on the smaller block when it is displaced through a distance x about its equilibrium position. Find the normal force on the smaller block at this position. When is this force smallest in magnitude? What can be the maximum amplitude with which the two blocks may oscillate together? These are two blocks, M and K. Time period of this system T will be 2 pi m plus m by k under root, and omega will be k by m plus m under root. This system is displaced x distance. Suppose m वाला m मास इसका है, that is block A, and capital M is block B. This displacement is given x. A part. Find the resultant force on the smaller block when it is displaced through a distance x from its equilibrium position. तो डिस्प्लेसमेंट जब x है तो FBD फॉर ब्लॉक A this is block A and इसके नीचे is block B. A पर अगर फोर्सेस देखें तो A का मास m है, तो वेट विल बी mg, that is downward m into g. Force due to block B is vertically upward is n, and acceleration of A is downward A, and this is omega square x. Net downward force on A is mg minus n, and that will be equal to ma. So mg minus n will be m omega square x, and m omega is k by m plus m under root by square mk x by m plus m. This is net force on block A, mks mkx m plus n. Part B. Find the normal force on the smaller block at this position. From equation 1, N will be, normal force is mg minus mkx upon m plus m. This is normal force when displacement is x. B का second part, when this force is smallest in nature. Second, this is first part, and second part. N from equation number 2, N will be minimum when mkx by m plus m or x is maximum. ये पार्ट मैक्सिमम होगा तो n will be minimum. For this condition, x should be the maximum value and amplitude A. X की value must be equal to amplitude. जब मैक्सिमम डिस्टेंस पर होगा यहाँ से एट एम्पलीट्यूड, normal force will be minimum. What can be the maximum amplitude with which the two blocks may oscillate together? C part. Equation number 1, mg minus n is equal to mkx by m plus m, or n is equal to mg minus mk x by m plus m, and n minimum mg minus mk a by m plus m. For maximum value, maximum amplitude with which the two blocks may oscillate, for maximum A, n minimum must be 0. So 0 is equal to mg minus mk A max by m plus m, or mk A max by m plus m is equal to mg, m से m क्रॉस हो गया, A max is equal to g m plus m by